In this presentations we are going to discuss about copy on write. So the contents are copy on write definitions and descriptions and the need of the page replacement, the allocations of a phrase. The copy on write allows both parent and child process to initially share the same pages in memory. If either process modifies the shared pages, only then is the page copied. Here, the copy on write allows more efficient process creations as only modified pages are copied. In general, free pages are allocated from a pool of zero fill on demand pages. Pool should always have free frame for fast demand page execution. Don't want to have to free a frame as well as other processing on page fault. Why zero out a page before allocating it before? That's in variations on the flow system call as present, suspend and child using copy on write address space of parents. So that is a designed to have child call executions and it is very efficient. Before process 1 modifies page where the process, so the structures of the page modifications before in the process. Okay, so next after the process 1 modified pages. Here after the modifications, if we need to add more pages, so that make a copy for that particular page C in the physical memory. So after the modifications, so what happened if there is a no free frame? If in this modifications we need to add more frames, so if any frames are unavailable, so in that time how to handle that situation? So used up by process pages, also in demand from the kernels, IO buffers, etc. So how much to allocate to each page replacements? Okay, so find some pages in memory but not really in use, so page it out. So algorithms and performance is also that here the important constraints. So the same page may be brought into memory several times. What is a page replacement? Prevent the over allocations of memory by modifying page fault service routine to include page replacements. Use the modified bit, that's a dirty bit, to reduce the overhead of page transfers. Only modified pages or written to disk. So the page replacement completes the separations between the logical memory and the physical memory. Large virtual memory can be provided on a smaller physical memory. So the need of page replacement is, so in this process one has the page B, so it refers in the physical memory but it is not available, so it is in the backup storage. The frame is also not available in the physical memory, so how it can be get the data B? So in that time we need to perform a page replacement. So the basic page replacement is find the locations of the desired page on disk. Find a free frame. If there is a free frame, use it. If there is a no free frame, use the page replacement algorithms to achieve a victim frame. So bring the desired page into the free frame, update the page and frame table. Continue the process by restarting the instructions that causes the trap. So here the page replacement is described. Here which page is not in use frequently, so that is the victim page. So first we have to find out that victim page, then it is swap out victim page to the external, that's in secondary storage, then that's in backup of a storage, then change it to invalid in the page table. Afterwards the needed page is taken from the backup storage to the physical memory, then reset the page table for that new page. So page and frame replacement algorithms, frame allocations algorithm and page replacement algorithms. So the page and frame both are the used for the storage. Okay, so the frame allocations algorithm determines how many frames to give each process, which frames to replace. So in this page replacement algorithms want the lowest page fault rate on both first access and re-access. So evaluate algorithm by running it on a particular string of memory reference and computing the number of page fault on that string. String is just page number, not full address. Okay. So repeated access to the same page does not cause a page fault. Results depend on number of frame available. In all our examples, the reference strings of the referenced page number is considered 7012, so like that. So consider this reference. So in this first in first out algorithm, this reference strings are framed by 3 frames. Okay, so 3 pages can be in the memory at a time per process. So we visualize the 3 frames. So in the first step, the first string, the 7 is placed, the next 0 is placed, next 1 is placed. So next the upcoming string is 2, so it is replaced by the 7. The next is 0, it is already available in the frame structure. So you have no more process, no more replacement. Okay, so the next one is 3, the 3 is not available in the frame, so it is replaced the already available frame, so that is a 0. So in this process totally 15 faults are occurred to completions of this referring strings. So in this optimal algorithm, here replace the pages that will not be used for longest period of time. So first 7 is placed, then 0 is placed, then 1 is placed, then 2. So here is replaced by the 7, then 0, it is already available, then 3, so it is replaced by the 1 because here the 0 is already used 2 times. Okay, so it is longest period of times it already available for the processing. So it is replaced by the 1 frame. So that is an optimal. So based on the needs. Okay. So in this least recently used algorithm, so here use past knowledge rather than future. Don't worry about that future. So use the past knowledge. Replace page that has not been used in the most amount of time. So associate time of lost use with each page. So here this type of algorithms have 12 faults, better than the first in first out, but worse than the optimal technique. So in this enhanced second chance algorithms, so it improves the algorithm by using reference bit and modify bit in concept. Take order pair. Okay, so 0 0, so either recently used, not modified. So 0 1 not recently used but modified, 1 0 recently used but clean, 1 1 recently used and modified. So based on this probability values it can be used. Then counting algorithms keep a counters of a number of a reference that have been made to each page. It is not common. So least frequently used algorithms and most frequently used algorithms are available here. So in this page buffering algorithms, keep a pool of free frames always. So then the frame available when needed, not found at a fault time. read page into free frame and select victim to evict and add to free page. So when convenience switch victim. So possible kit list of modifications pages. Then applications and page replacement. All these algorithms have OS guessings about the future page access. Some applications have better knowledge. Then memory intensive applications can cause double buffering. Then operating systems can given direct access to the disk getting out of the way of the applications. Bypass buffering, logging, etc. These are the applications. Thank you.